Hi, my name is Michael Spivey, and I've been a professional software developer for many years. And today I was going to take a little bit of time to talk about making software more flexible, and we're going to use the strategy pattern. So what are some of the benefits of making your software more flexible? One is you're able to respond to change more, so you can change faster. The other is you can try more implementations. Maybe the business says we want this option and this second option, and if you don't program your software correctly, then you might have programmed yourself into a corner where you can say, well, we can do one or the other, but we're not going to be able to do both. It's just going to be too difficult. There's too many dependencies, and we're not going to be able to swap the two different implementations out. Hopefully, if you write your software using the strategy pattern, then you'd be able to say, oh, okay, you want these two different options, we can afford you that. So you can change faster, you can try implementations, and what this does is make the business more competitive and hopefully save money. And the reason you can save money is because, one, you can try more implementations without adding a lot of work, in that you're just affecting one isolated part of the program, a specific implementation. And that's one of the benefits of using object-oriented programming and encapsulation. So you're encapsulating your logic in this one implementation or strategy, and then because it adheres to the same interface, it'll have the same API surface for all the rest of your program to interact with. Then you can make different encapsulations. You can make encapsulation A, implementation A, or you can make encapsulation B, implementation B. And one way to think of it is kind of like your socket in the wall. You know that you can plug in a vacuum cleaner, a computer, anything into the wall with this with the two prongs. That's the interface. You don't know what's behind the wall. In some buildings, there might be a certain wiring infrastructure and it's backed up by a nuclear power plant. On the other one, it might be backed up by a solar power plant in slightly different wiring. But the interface, the plug, remains the same. Alright, so let's see how this works with a simple diagram. So one way to think of or conceptualize your classes in your software is to just draw simple diagrams. Alright, so let's say that you have your application code, and I'm just going to draw this as one big rectangle. This is every place in your application, every piece of code. And then let's draw an interface. In C#, you can do this, in Java, and you can do it conceptually in almost any language. But C# and Java have native constructs for this. Alright, so let's say we have our interface here, and it's going to have a doWork method. And it'll take 0 parameters. So at this point, what we've done is we've said we're going to have this interface. Now we're going to have a class, right? So let's say we're going to name this one the SQL implementation. So this will have a doWork method. Now, traditionally, when you start programming, you're going to write your apps not thinking about this interface here, right? You just get in and you start coding. You say, I'm going to do this, right? I'm going to have my app call this SQL implementation class directly. Now the problem comes into, the business says we need to reduce our costs, and we're not going to use SQL anymore. So the CTO says we're going to start looking into NoSQL options. And in the meantime, you see in this very simple app, there's only one class, but you might have many different classes all trying to get data and write data to your SQL database. And the problem is, when are you going to switch it out? Are you going to have to switch them all out at one time? and manage that transition, in which case you'd be writing new classes and moving it over in every different. So let's say you have infinity, let's say a couple hundred references to SQL implementation do work. And then let's say you have your NoSQL implementation class that does the same work, except it doesn't go to a SQL database, it goes to a NoSQL option. So if you had programmed using this method over here, or style of programming, then you're going to have to go through your whole app, and if this is 50 different dependencies, you're going to have to go one by one and change them to now point over here to NoSQL implementation. And then after you do all of that large amount of work, then you're going to want to test and then deploy. There's using the strategy pattern, we insert this interface here, right? So we have all of these application dependencies on this code go to the interface, and then what we do is we swap out the interface. So one way to do this is using a factory to decide which interface to use, and the other is a context object. And in the strategy pattern, it's usually a context object. So let's say we'll have a do work here, right? So, and we'll have an interface variable. So this is a variable that holds a reference to this a specific implementation of this interface. So you might have something like this, right? And then now all your code is calling this context class, and behind the scenes your context class has a private variable of type interface, or the specific interface. And then in its constructor or any other place, you can say, hey, I want to instantiate a SQL implementation for the variable, or I want to implement or instantiate a NoSQL implementation. So that can be determined in the constructor, or you can have a factory class. And this just would have a method like getInstance, and it's responsible for choosing which implementation you're going to get. So now with this setup, you can put in your config file, for example, which implementation you want to load. And so now it has become as easy as which implementation do you want the app to work on right now. So you've developed all of this and all this code, and you're now writing tests against NoSQL implementation. Then you set your config file to load the NoSQL implementation, and you go about doing your tests. While the customer says, I need this fixed. And so right now, all your customers are working off of the code that uses the SQL implementation, because the NoSQL implementation hasn't finished testing yet. Well, you can still use the SQL implementation in the production environment, just set the config file for the SQL implementation. And you can still go into the SQL implementation and fix the error that's showing up just in that implementation. But this is a great way, and you can make a third, fourth implementation, and you just keep going, over time. You might start off with, this might be the year 2000, and then 5 years later, the business wants this implementation. Or the business says, hey, we're not very confident in of these two ways. So you can say, let's make a second implementation here. So we'll just name it the third implementation. Right? So you can develop them linearly, or you can develop them in parallel. So you can try them both out and say, oh, this one, the costs really were reduced a lot. So okay, we'll go ahead and go with that one. Or we built these two, and this one's a lot slower than the other one, and we really need the speed. So we'll go ahead and go with the third implementation. And it was just basically allowing the team to create all this software and manage it without overriding the different implementations or saying I can only choose one of these. So that's an overview of the strategy pattern and how it can help make your software more flexible and hopefully save your company money and make you produce your work faster. Thanks.